substitute the report from USSB. My name is Andrei Pitukhov. We had supposed to get Jan Shashvili from Santa Barbara University, but in general, as we have spoke with him on the stage of editing his work, he asked me to convey his main ideas of research. Short disclaimer, I'm gonna tell you about the main ideas and that added value which guys made about identification of vulnerabilities and various devices. You can ask all the questions to the authors of this research. Their contexts are going to be presented at the final slide. The important point is the Santa Barbara University and guys who have applied their hands to any research in web security, identifying the attacks, so they are, well, the fathers. Many may know Christopher Kruger, Johnny Winnie, the fathers of the oldest CTF, what the guys are actually were doing.
Известен тренд по увеличению количества устройств в области интернет-вещей. То есть сейчас
Internet of Things. Anything could be managed through web interface. This graph of random analytical agency, which was made in random time, shows sustainable growth in the number of devices that have some installed base, and for these devices we mean home routers, web cameras, electronic locks, could be even Wi-Fi toothbrushes which could be switched on remotely and other things. And the main motivator of this study were published recently. Studies on backdoors, which were backdoor possibility to manage the device without knowledge of login password of the user, which are the users and manage these devices through any service account. As an example, we have devices 3S Vision and 5072, which after studying it was identified that they have a backdoor. So any person that has access to this particular backdoor could get a username and password. It was one and the same devices, and they could manage these devices remotely. So there was a question: how can we approach systematically the analysis of this identification of these drawbacks for this with a scalable way? There was a method proposed. Let me tell you the idea a bit later, but let me get you the example of what drawbacks we'd like to identify. We'd like to identify three types of drawbacks. First, hardcore login password. There's an identification procedure. You enter login password, a secret, and a special contour. You compare the embedded line. If it coincides, that the granted access. If it's not, they check the login password the user has configured for itself before. If it coincides, again it's good. If it's not, then goodbye. First type of drawback, which we will call backdoor, possibility of bypassing authentication. Second type of drawback is related to the hidden administrative interface. If you know that you don't have to enter any secret, for example, if you're talking about the web admins, that's kind of a path within web admin consisting of 20, 30 random figures like 1, 0, 5, 16, IDF, etc. Moving on this path, you can get to admin function without entering login or password. And the third type, which is get in scope of work, vulnerability in web interface, the control panel, which allowed to introduce OS commanding or remote code execution. A good example, if your router allows you to make ping, you get that into the entry field. Now if you want to ping, in fact, this entry, you get this entry and you form the system command for Linux that the router ping works at, ping the argument that you have entered, and then the system command is performed. Therefore, if the user entered the correct way, you can add any command through, and it could be executed in any operating system. These three types of vulnerabilities got at the scope of this work, and they are called possibility of bypassing authentication or simply backdoors. Well-known examples will describe what is the idea of system analysis with embedded devices. In search of these backdoors, so what we can do, we can set up this vulnerability model. If in the program there is no authentication procedure is called, we believe that the program is vulnerable. This approach doesn't work because the procedure identification might not be available at all, and we must admit this could be admitted as a vulnerability, and then any identification procedure is implemented in all the devices in the custom base. We cannot set up same signature which would be applicable to Linksys and the link cameras and other electronic locks. So what is also painful is that static analysis of such beds is hard because they're written with different architecture. They are supplied without the initial code, as you understand. You need to have a statistic analysis of the binary code. Dynamic analysis is hard because we don't have access to the calculator that it works with, so such access that you can observe and monitor the environment, time of performance, and also most often we cannot instrument that, this beds because they have a electronic signature approach, etc. So that's a problem. So how it is proposed, main idea to fight against this problem. The main idea is search for not the absence of identification procedure, but search for the opportunity of getting access to critical function, which must be close with the identification procedure without entering the secret. In other words, if we analyze, imagine we can identify what entry we need to get to the program to get to the secured function, then it means that we need the possibility to go around the identification. So that's the model, that's the approach. The identification procedure, in this option we enter a secret which only user knows, which could be analyzed statistically. So there's a connection between the and in case we have the access to critical function. So in this identification we have a chance of choosing this input data, which are calculated again having access to binary Latin code. which allow to get this success. That's the that it is proposed to check. The question is with what methods? As it was said before, probably through dynamic methods which are not perfectly fit. Exactly, we don't know. We don't have access to digital calculators that we have to use statistical analysis. Keeping in mind availability of different architectures, we need to somehow unify internal and then we need to unify the approach. So then, the first idea. Second idea is how we are going to understand which of the analyzed bits function is critical, where we cannot get access without getting a secret. Unfortunately, in automatic mode it is not ever possible. Everybody understand that, and therefore it was suggested to the analysis to get specification which functions we believe critical and which are not. In other words, for the embedding is analyzed and specific functions which we protect access to. With which methods it is proposed to resolve this challenge and having embedding and specifications of functions where we trace. First we have statistical analysis, and for each critical function we build a backslice which allows to get only those program operators which input data that move from the user's input to this very critical function, and then each backslice sent to the same dynamic symbolic execution procedure. At the end, we can get specific inputs or limitations on the input data which would allow pass the way shown in this backslice and reach this critical function. So after we receive that known limitations on the input data allowing to make the pass from the beginning of a software till the critical functions, you need to check that it was not false, which is truly implementable. So then we make the third step, which is authentication bypass check. Like if this input data were found, and we declare that we found relay bypass. And these are the data which must be given to the input. If we didn't find that, we cannot say anything because our method will not work, but in general, we might be sure to some extent that in this software um, there is no possibility for authentication. The procedure which I told about is shown on this slide, then I'm going to skip some of the slide. I'm going to go exactly to the tools which was implemented for automation of this analysis. This is called Python. It allows to upload to the special environment the analyzed set, and we can get rid of any values of any variable. Then with this tool, using the IP framework that the guys have written, can make dynamic symbolic execution until the required point. The third, this software allows to make backslice till the required point. So these functions supported by the framework which was laid at the GitHub is urged to use, test, maybe write comments into this repository, and possibility to write about feedback whether it works or not. There's a link to GitHub and the email address where you can ask questions to. At that, I think I've told about the idea, tools. If there are questions which I might be able to answer, go ahead and ask. If no questions, thank you very much for your attention. And at that, until 2 o'clock, we have a break.